Hey friends, hope you're doing well. In today's video, we learn how we can chat with YouTube videos. Yes, you heard me right. We're gonna chat with the YouTube videos and then we ask our questions and get responses. Now, before I forget, if you like this kind of content, please subscribe to the channel and also click on this bell icon to get notified when I upload new videos. Thanks a lot. So let's get started. What we're gonna use is langchain framework for Python, and we're gonna also use OpenAI so that we can use ChatGPT. But I just want to mention this, we can also use a different kind of LLM, for instance, any kind of open source LLM. This would also work. So let's get started. Now, in this case, we're gonna use the YouTube loader. You can see this here, which is a class, which is really handy because it allows us to download actually the YouTube transcript. And if we get a transcript, then we can simply then read this transcript and embed it in a vector store. And then we can ask different kind of questions using the large language model and the vector store to get our response. That's the idea behind it. So the way it works is, of course, first import a few dependencies here. You can see we got the YouTube loader here. We also get a recursive character text splitter, so we can split the transcript in multiple smaller text chunks, because most often, especially if we're dealing with very large and long YouTube videos, then probably the script is very long and you can't feed all in the context. That's why we basically do this normally. So next we need some kind of vector store, and I decided to go with Face here, or Face, depending on how it is pronounced. But in general, it's a vector store which reads the data in memory. So it's really handy, very easy to use. If you want to use it in production, I probably would use something else. So you might want to then refer to maybe different kinds of vector stores like Pinecone, and the other ones out there probably as well. So just to mention this, Face is rather for, I would say, experimenting. That's at least my point of view. Okay, next we need some kind of embedding for the vector store. So to transfer, or actually to embed the text we have in vectors, so in numerical representation, and we're going to use OpenAI embeddings because we only use OpenAI for the vector store. Now, as you can see here, for the large language model, sorry. You can see that when we import here OpenAI, which is the class which allows us to then refer to the OpenAI endpoint and then call the ChatGPT model, depending on what kind of subscription you have. Could be 3.5 if you want to use it for free, or also 4. Of course, you could also use this as well if you want. So then for the prompt template, we're going to use a specific prompt template, which just means that in the prompt template, you will see this. We will not only ask the question, but we also want to feed in the documents actually, what the large language model should then use in order to answer our question. And the documents will be the relevant text chunks, which get extracted from the vector store based on the query we have. So then, of course, we're going to use environment variables. I'm going to use load.env, which is really, really handy. All you need to do is you need to have your .env file where you store your OpenAI credentials, in this case, and load it into environmental variables to use it. If you're going to use some kind of open source model, then of course that's not required. But if you want to use OpenAI, then you have to do this. Or, of course, you can also use your OpenAI key directly in here and store it as here as plain text, but I would not recommend this, especially if you publish this then to GitHub or anything like that. So then I'm going to use a few functions here. You don't have to create functions for that, but I think it's cleaner code, so that's why I did it here. And we have the creation of the vector store, which uses a string, which is basically the YouTube video, and then it creates a vector store here. So we have the loader, which uses the YouTube URL. It loads just the transcript of the YouTube video, and then it loads the data and stores it as text, or actually more as documents. And then we use the character text splitter in here with a chunk size of 1,000, so 1,000 tokens, and then it gets chunked. And then if you want to have an overlap, you can do this. In this case, I decided to go with 0, but it's up to you. This is, of course, for experimentation, what you want to use. Next, we split it into documents. We split it with the splitter in 1,000 chunk sizes. And then we have the texts, which are actually documents now, which is a class inside langchain. And then what we do is we create also the embeddings here with like this. And then, of course, we put basically the embedded text chunks inside our vector store, which is this case the index here, and then return the index. That's basically this create vector store function, which I've created here. And then I have another function, which is simply then using this vector store as well as the large language model in a chain to get the response. And the way it works is the following. We have basically in this function here 2 arguments. We have the vector store, which gets created from this method or function, and we also have the query. And we also decide k. K is just how much, documents do you want to actually put or give actually the large language model from the vector store. So basically what we do is we query the vector store based on the similarity measure. That could be cosine similarity or anything like that is often used. And that we basically do, we have a query. The query gets embedded into a vector. Then the vector is compared to all the vectors we have in the vector store. And this is done here with the similarity search. And then based on the k, which is by default 3, then the 3 closest vectors are returned. That's the idea behind that. I also print this here. You don't have to. You can also comment this out. And then I simply extract from these vectors, because they are basically documents actually, I extract simply the text itself inside these vectors. And then I join this as a longer string. And then I instantiate here the model. And then I have my prompt template. You can see it here. It has a question and docs. And then you are a helpful assistant that can answer any questions about the YouTube videos based on the transcript here. And answer the following question. Question is one parameter which you give here. And the second one is docs, by searching the following video transcript and then docs. And these docs is not the full transcript. It's only the vector which is relevant to our search query. So that's what we create here, the doc embeddings. These are then put here. So the large language model can read actually the relevant documents from the vector store and then answer the question based on those documents. That's the idea. And as you can see here, I don't want it to make things up, so only use factual information from the transcript to answer the question. If you feel like you don't have enough information to answer the question, say I don't know. Because I don't want it to simply generate a response which actually it just made up and which is not correct. And that's it actually for the template itself with the two variables. So as I said before, we have the question and we also have the relevant documents from the vector store to answer the question. And then we create the chain. Simple LLM chain, we give it the large language model, we give it the prompt, and then we run the chain with the question. We also have the embedded docs here, which we give, and then we say here, just replace \n. I just replace the line breaks here, and then I just return response and docs, and then I give it here a URL, and then I want to create the vector store first, and then I generate the response. So the two functions we gotta have created here, those are now called. First to create a vector store in here, as you can see, then my query, and then the response. And you can see here, I'm querying a Dragon Ball Z video, which I found on YouTube, and I just ask what is Son Goku's goal, because in this video, Son Goku is fighting Frieza. Okay, that just as a background here for you to know. And very important here for the YouTube loader, just in case you want to also do this or try this out, make sure that you do not paste, as you can see here, do not paste the whole URL from YouTube, but only this last part of the URL. You can see that's in the URL itself, and then there's some kind of random number like this one here, or letters, and this is the thing you need to pass in here in order to actually make this work. Because first I tried it with the whole URL, but this doesn't work for the YouTube load, at least from my point of view, which I experienced. Okay, and now actually you can run this and then print the response. And if we try to do this here, let's do that. Let's run, in this case, Python and then uchain.py, like that. And then I run this here, and then we just wait until the data gets extracted, put in the vector store. You can see this here. And then we have a response here. You can see this here. Son Goku's goal is to defeat Frieza and protect the planet from destruction. He's determined to use his power to its fullest potential in order to achieve this goal. Yes, because this is where he transferred into a Super Saiyan, that's called, right? And then he's fighting Frieza there on planet Namek. And you can see here, this is basically, you can see here from the metadata, this is actually what the vector store actually found as the most similar vectors, okay, to answer this question. And this is what's then put to the large language model in order to answer the question. That's the idea. As I said, you don't need to print all of this, but in this case, I'll still have this in here with the print command somewhere here, where I print the documents which are most similar. But you can comment this out if you want. And the last thing I'd like to mention here is currently you can see this is in the command line, but of course you can also, we could create a front end for that, for instance with, I think, Streamlit or a Chainlit, or maybe also Gradio would be options in order to make a really simple but powerful and very good looking, at least from my point of view, web front end. So anyone could then, if you run this, could then just paste his or her YouTube URL in there and then ask a question, and then the question gets answered. And we could also print, if you want to do this, the relevant documents to answer the question, which you can see here, that could also returned somewhere on the screen so the person which asked the question knows also, okay, that was used in order to ask the question. Now, that could also be an option, of course. So if you want to see this, if you want to see the front end also implementation in here, just let me know in the comments. If you want to see something else, also let me know. Hopefully you enjoyed it. If so, please give this video a like one more time. And if you have not done so far, subscribe to the channel. Thanks a lot for that. Take care, and then see you in the next video. Until then, best guys.